Hi, Michelle. How are you? I will be.
Oh, good. Hi.
Okay, 1 second. Let me get the lab up for you here. Just uploading. We don't have too much to do today. We are going to run a few scripts. So if you have your Linux virtual machine available, you can turn that on. Should be ready now. And then I'll share screen. People are not coming in yet. So Lab 5 should be available now. Okay. Are you running your DNS on a regular machine or a virtual machine?
A regular machine, but I have 5 other devices that are working just fine. So it's just this one device that didn't have.
Possibly check to see if you have set it. Are you running it within your wireless network, right? Just make sure.
No, this one's Ethernet cable.
Oh, okay. So you connected to, but you connecting that to your wireless network?
No.
No, it's isolated?
No, it's not on the same network as the other devices, but it's through an Ethernet cable.
Okay, so that means that if you are bridging it over to your regular network, you have to make sure that the other ones won't be able to see it unless it's on the same network ID. So IP configuration there.
No, all the other devices are fine. It was just this one device that was connected by Ethernet cable, so that didn't make sense.
But it's still,
so
if you're still connecting to your router, right? Are you connecting it to your router?
Yeah, direct connection.
Yeah, so that's what I'm saying is even if you connect it with a cable to your router, and if it's not on the same network, your router will not be able to see it. It has to route to the router. So that means that if your IP address is not in the network, in the same network ID as your router, it will not be able to see it.
Well, it's all they're all set to automatic to receive the IP address.
Oh yeah, but for DNS, you shouldn't have it on auto. You should make it like 192.168.1.x. And then it'll be, and then the same subnet mask as the other one. As your router. Okay.
Oh, yeah, I guess I don't know why it would change because it was fine. It's been fine.
Yeah, if you dynamically assigning it, the next time it boots on, it might not be able to identify the records, because if the router is dynamically giving it a different address, it's gonna lose the record.
Okay.
Okay.
This has never happened before. That's all.
Okay.
It's just odd.
Because it does renew IP at times. So what you want to do is you want to use a static IP and then use that static IP to set up your DNS records. Because if you have established it with another IP, it might have lost the records and it will not work.
Okay. Yeah, I didn't know what the time lease was.
Okay. It should tell you what kind of failure. If you go on the DNS itself, under the DNS status, it should tell you like what's happening. All right, so let's talk about Tor and Python. We don't have a lot to do today, but I wanted it to kind of touch on some of the libraries that use. And these sets of exercises are actually part of the exercises the authors recommend. I do find that you know, if your endpoint or if your URL in Tor is not valid, which is in the case of some of the exercise, you will have some error issues. But when you read the errors, or sometime if the site is not responding back, you would be able to see that in the exception. Okay, so that's a disclosure that I would have for you. Let me see. Let me go back to the file here. So in this lab, we're going to touch on a couple of things, and the book talks about how you can use libraries or modules that were written by other people to be able to work with Tor. And similar to what we've seen in the prior chapter, this area is really looking at like how you can monitor traffic or status of certain things on Tor. And in order to achieve this lab, you have to have a Linux machine that will be either physical or virtual, and you need to run Tor with it. It will not work if you don't have Tor. You will have a bunch of errors because it's going to look for the service. So the two things that we're going to visit today is going to be, one library is going to be stem. And this is a controller library for Tor. You would be able to use it to manage your protocol in your script and your process, such as looking at NICs. And we talked about NICs last time. A second library that was implemented, and I'll talk about other services, will be Tor Requests. And this is a wrapper. So wrappers are basically decorators. It is used to be able to modify a certain function inside a class that's in a library. So you can use it to wrap with another function and extend how you want that function to behave. So without fully modifying it, because we don't want to modify the library. We're actually just want to modify or add some of the area for the functions or the methods. So in decorators, the functions are simply arguments in another function. It's like overloading functions in some programming language. You would see that. So we are using a function inside a function, and the functions are being passed as argument in another function. So you can use a decorator as a way to be able to implement a function as an argument. Okay. Now the link for the stem is located there. So if you click on the link, it's going to take you here. There are resources with tutorials. So if you want to listen and look for hidden service, you can go to specific areas. And then you can also find utilities and things that will be useful if you're using this particular library. So STEM has a lot of the details on how to implement certain script for Tor. And now when you use it in Linux, you simply just download the package and be able to do that. But if you read for the API, it does have additional APIs. So you can integrate API through STEM for Tor, depending on what you want to include. So here they list all the information on which would be useful as far as utility. So if you want to connect, if you want to use connection, that will be connection and IP related utility. If you want to do more configuration on the configuration file, you would use the stem-util.config and so on. So they have these pre-made utility for you to integrate. And if you need to explore Tor, you can implement stem library. That's one of the libraries. Then in addition to that, you can also see that we are going to look at Tor requests, And so now regular request library works with your normal HTTP, get, put, post, etc. For Tor, you would use Tor requests. And even if you experiment with setting up proxy with this one, right? You have to make sure that your Tor request is going to be downloaded and installed. So you can do that through your terminal. And then when you set up, you can set up your ports. You can use it like how you would use in a regular request. So in this one, they give you some example on how you can put in a URL, but if you're using Tor, keep in mind that you have to use the .onion sites, right? Instead of like the .com or your normal URL. Now, if you try to use it with the normal URL, you will not be able to get much information because it's going to not be able to get some response. So in the case where if you want to attempt the get, you just got to put in the endpoints that would be appropriate with the .onion. Okay. So on here, you would see that this is their GitHub repository. It gives you some example, and then you also will be able to set up your source code. So, right. Any question regarding STEM and Tor requests? So if you are using your Debian Linux release for the first time, right? If you downloaded Kali and this is the first time you use it, you have not used pip, you will have to install pip. So the first part of this just simply walked you through installing pip. Once you have pip, you can put in any of the packages that you need. So as you look at your script, right? If you're using a certain package, you simply just bring that in by using pip3. Okay. So let me get my close this real quick. Open terminal. So the first thing that we want to do is to make sure that we have pip. So you just do sudo apt install pip3, or I'm sorry, Python 3 pip. And in my case, I need to validate that I am a super user. So once that's installed, then you can install the packages. So we would do a pip3 install request. And this will work with the prior lab in here if you wanted to run some of the script from the prior lab that use requests or any of the program that would import in requests. Okay. Now, request it has a wide variety of things that you can implement. As we talked about last week, you can also see that on their documentation, you can use some of the existing utility and tools from the request. Now, we can also install PySocks. So you can do pip3 install PySocks. And then if you want to do Tor requests, right, you can also do pip3 install. Now, even in the name, it says Tor request with an S, but if you use the same name in the command prompt or command line, I'm sorry, pip3 install Tor request, make sure you don't include the S. Otherwise, you're going to get errors. So as you can see, I have installed that. So it shows that it's already been satisfied, but as you do it, it might prompt you to say yes if you wanted to save or write to file. So we can bring in some of these modules to be able to use for various scripts. And so before you start writing your script, you want to make sure that you install these packages and modules through terminal. Okay. Now, since we're working with Tor in the assignments, we talked about how we can start Tor. We can start Tor by initiating the service if you already have it installed. If you didn't do the assignment, you have to do the notes section in step 4. So if I want to initiate my service or start my Tor service, I simply would use that command. We would do sudo service Tor start. And it's simply, if it successfully started that, it will just go to the next line. If it's not able to communicate or something is wrong with your network, you will get some kind of error there. Now, if I didn't have it installed, it will tell me that it doesn't recognize it. So it doesn't have the Tor in order to start the service. So you have to do these. So you have to push updates, install Tor, and then restart. So for these scripts to go, we just got to make sure that we have the appropriate libraries and the Tor service. Now, in the case where when it's trying to contact the endpoints or the URL and it's not able to resolve that, then you might get some kind of information coming back saying that it's not able to get response, and it would handle it as exception. So it varied from what kind of websites that we would use, right? So for the next step, we are going to use Nano to write your code. Unless you have something installed on your Linux machine, like a text editor, you can definitely use that, like Sublime or something else. But we can use Nano directly in our terminal to do that. And some of you have had me for 30E, so you're familiar with this. But if you haven't, you can call on the text editor inside the terminal and you can write your script right from there. If you don't have Nano, you simply have to install it. So if you're writing this command and it says that it cannot detect, it doesn't have Nano, so it will give you a line suggestion on how to install it. So you would have to do sudo apt-get install or sudo apt install Nano. Okay. Like that. And once you have Nano, then you can use Nano to write your file. So in step 5, it tells you to create a file. So when you're using Nano, you automatically just gonna start with giving it a name. We would just name it requests proxy, and this is the script that's provided by the author. So we're gonna run it, and we wanted to check it so that way it shows you how you can establish your socks, and also, you know, using a certain port. So we'll look at your script. Okay. So you're gonna call your file request proxy.py. And as you open it, unlike what I have, you're gonna see nothing here. You have to write. And you don't have to include all the comments. That will be some of these lines are comments, but if you add the comments, it's gonna help you verify what that section will do. So in this one, we're using the request module. And we start with the function. We want to get the session information. Recall that when we talked about this on Monday. Session information is only valid when that session is alive. As long as it's alive, you will be able to have some information about it. But if once it's ended, right, that's gone. So what we want is we want to establish a request session, and you are using your port 9050, or sometimes we would use 9051, and this is the common port for Tor. So what you can do is you can set up another system as your proxy. And in this case, we would use our local system, which is how you would see it. It's using the loopback address there. So whatever system IP that would be, you would include the IP here and then the port number, and make sure that we enclose that in the quotation mark. So this would create a dictionary, and for that dictionary, we would use the key, and our value would be the address of your proxy. Now, some companies, they would use more than one, right? Or many, 100, 1,000. It all depends on the scale of the traffic that they're working with. And then the app from the function, we want to return the session, which is going to contain our request information. Now, on the next part here, it's simply going to print your normal public IP. Okay. So this is going to give the IP. So it's going to go and it's going to visit the site, right? Like what we've seen in the past where we use the get. So it's going to visit HTTP bin and the IP address. So it's going to find the IP, the public IP of this domain. Why do we need to do that? We need to do that in order to pass it from our proxy over. So the way that you can use proxy is proxy can be used as a middleman to filter, to screen, to block, to monitor, right? A lot of companies would use proxy on the network to really monitor all the traffic. So for all the users that are connecting through the proxy, we can block certain sites when people are trying to issue the get and to a certain URL. We can also allow those sites, but also monitor the type of traffic coming back. So in general, that's what proxy does. But it also can be used to connect to things quickly, right? Like we can pass it through many different proxy in order for it to divert the traffic instead of going our normal route, which can be bottleneck. So here we are going to print the public IP information for the bin.org. Now on the next part here, it shows you that you are going to do, you are going to store the get Tor session. So this now session outside of the function that we previously defined, it is declared as just to be able to obtain your Tor session. So here you see that their example, it uses the HTTP bin, but you should, when you're using Tor, is you would use the onion site. And if it is an active onion site, it should respond accordingly. Okay. So when you run the script as is, you're gonna see that, you know, it's gonna run into issues with your regular site as we are looking to do Tor service, as we use the method that was implemented for the library to get Tor session. So this is why sometimes you will get the traceback saying that this is, you know, it's running into some exception that it's using the regular site. Now on the third part here, what we're doing is we're trying to get the response from the server, and this is an onion site, right? Your Facebook core, www.i Now, if this site is responding and it's active and it's valid, then you will be able to obtain the header information as a dictionary. Okay. Any question? Now let me uncomment these out so I can show you the complete. And then when you, after you're done with writing your file, you simply hit Control X. That's going to prompt you if you want to save to the buffer. We can press Y on our keyboard to say yes, we are going to save. And it's going to say, do you want to keep it the same name? We're going to just press enter. So after you write your file, to run your file, you simply call on Python. So it gives you, it did go through, and as the interpreter runs through the line, you're going to see that it did give you the public IP, right? So the origin is this, the IP for Tor connection is this. Okay. Remember that we talked about how these relays are used. So the public IP that you're getting, it's not your system IP. What the IP is shown there is really the IP for all the one of the IPs for the relay that you were using to visit Tor. Okay, and that's the public IP that it sees. Now here it's going to give you some traceback, right? It's going to say that it cannot establish the address. And you can take a look at, so what it's trying to execute some of the built-in options from the library and be able to trying to access it. So like I said, if you have issues with connecting to certain sites, for example, when you get to right here, you can see that it has SOCKS, HTTP connection issues to that, you know, whatever website that you're gonna connect. So if this onion site is not responding, right, you would run into a traceback like that, and that's okay. So take a screen capture and give me an overall summary of what the script is designed to do. So it's supposed to give you your original IP, right? And then your Tor connection IP. And it's supposed to give you some information from your session, which should be responded from the server if it is functional. Now, from the time that the book was written until now, there could be changes in Tor. And so keep in mind that, you know, while the example had worked for the author as he screenshot that, if that site is no longer active or it has changed, then, like for example this one, then you are going to get an error. So if you plug in a valid onion site, then you should be able to get some information there. So we can look at proxy information or what was sent to the proxy, because the proxy would be able to recognize the headers and so on. Yes, I do too. It could be also that it's blocked. So if you're getting connection refused, that's fine. Okay. It's also that it's not able to, it's gonna give you, it's not able to give you the response back here, or it refused to do that. Okay. So if you have active sites that are accepting traffic, then you would be able to get something back. Yeah, I got that too. Connection refused. So it could not establish the socket. Therefore, if it doesn't establish the socket, we cannot get the response headers. So that's why you're not going to be able to, that's why you're getting all those traces back. So I put for number 7 that after you ran the script, you will run into error on the script. Look at section of your error, like what Michelle said, that she saw connection refused, right? Who is refusing the connection, right? Is it HTTP bin or is it Facebook core? So look at your error and explain how those error occurs, right? And sometimes active and alive servers, they can also reject certain requests from a certain proxy, right? Or proxy in general. So sometimes it has to be directly from the client. It doesn't want you to pass it through proxy. So that might also be the case. If you send it through another system, like a forwarder, it would not be able to accept it. And they do that for security reasons, in that, you know, for attack purposes, they want to make sure that it's coming from individual client to server type of environment. Any question on 7? So if you haven't installed Tor Requests, right, you can, I don't know if I added the script for that. I don't like it. So you might not have to even do this one. Okay. Now, if you do test some of the script in the book, I know that he provided a link at the beginning, and we talked about that link, so you can download the script. You will see that in some of the script, when you're importing only specific things, you might want to import the whole Tor request module instead of different elements of the module, as it might not be able to find some of the methods and so on as you import in the element that's not the entire module. So this one is an anonymized Python script, and it uses socks and socket. Okay. So you can also check to make sure that you have your module. Okay, and then we're gonna do a pip sockets. Find the version that satisfies the socket. See. Then next we are going to write the anonymized file in Python. So we're going to do a nano anonymize. And then you can start writing your file there. Save it. That's something else. Okay. Well, we'll just move forward. Any questions? Let me share my screen here. Okay, so in the script, it shows you a few things. Number one, it shows you how you can establish a socket, just like how you would in the regular HTTP programming. But this is for the Tor. So you're using these libraries and you are going to have the socket. And socket simply is a way that we can implement connection. Okay. So in the first function, this, right, allows you to create a temporary connection. Then you are going to establish the proxy and using the loopback, that is your home, your system home address. Then like what we've seen in the other type of socket here, the only difference is we're using socks. So we create an object here in the third function. And this allows us to use the IP address, right? That was part of the address. And then also the source, there's none. So we are creating a socket. And in the socket, you can establish IP, port, and protocol. Those are the three things that normally goes in the socket in all HTTP, regardless whether it's Tor or not. So with that, we want to return sock, which is the object for the socket. And then we would set it. Okay, so that will allow us to do the connection. After that, you would save the file. And then you can run it. So ultimately, the purpose of this is to be able to establish connection, correct? But when you look at this, right, the function is really to enable proxy and you using your system, right, and the port number for Tor to be able to establish the connection for Tor. So it is a way that we can set up a socket for Tor network. Now, unlike your regular socket that you've seen with like TCP and UDP, remember how we talked about the type of the datagram and the stream, right? For your Tor, right, when you do this as a proxy, you have to set up the proxy type. And when you do Tor, it's usually SOX5 is the type that it's going to use. Any question? Okay. All right. Then after you run that, you should be fine running that program. And so for the next program, we're only going to do a few today. So for the next program, you can call it anything you want, but I think I call it the status. Let me double check my. This one. Okay. So for the third program, after you run anonymize, right? You can reopen Nano and you can make your program. And in this one, we're actually using STEM module. Okay. We use STEM module to check your Tor connection status. So for here, we would see that we're gonna use the STEM module and we're gonna use the control or the controller. In this program, we create an object called controller, and this controller is gonna control the port, which is the actual abstract level of connection for Tor, right? Which is 9050. Then it's gonna do authentication because as you recall that every level it encrypts. And so in order to get your network status, it needs to be able to authenticate to whichever entity that's handling the traffic. And at the first level, that's going to be your beginning relay. So here we are going to use the network status or get network status method. And it needs to iterate through it. So it needs to be able to print out router information and nickname. Because remember that the directory was offered initially when you connect to the relay, right? And so we will see if you are successfully sniffing out the traffic this way in Tor. Okay. So the program is fairly short. You just establish two objects. One is going to be the controller, where it's going to look at the port that it's connecting from or the source. Okay. The second is where it's going to look at the entries and it's going to try to get some status information from the relays. So it's like doing trace route, right, in Tor. So once we have that program, save it and run it. So we are getting also an additional connection refuse, right? Like what you've seen previously. And also your control port, it's not able to get that. So you should get some exception handling in that it's refusing connection. So we're not able to get any kind of status as it didn't connect. So the level for security for Tor, like what it was explained in the text, and also when you look at the website, right, you would see that you can attempt to script and listen or look for certain details, but unlike regular HTTP, you are not able to do that. Now, if you want to, if the connection is allowed, then we would be able to get some details as far as, you know, the socket that it's using and so on. Any question? So the script runs successfully for 14. Of course it did, right? But you do run into exception handling that your connection was refused. Now, if you're interested in using Tor requests, you can also, I think the book has like one example that's using Tor requests, a simple one, or you can use the example on their website. Just keep in mind that, you know, you are going to use specific URL, and it will only work if it's a valid Tor URL that you have. So, you know, you can try to find something that works, that already exists, and then you can implement it. So on this one, it shows you how to use the get, the post, very similar to what we've seen with URL lib or requests module overall, right? Tor requests it has the same functionality. It's just operating at different ports. There are some minor changes in, you know, in your methods. Okay. But because the way Tor is designed is it's using encryption, so all of these libraries are equipped with cryptography to be able to handle, like, you know, certain tasks for the Tor network. And I think they have a typo right here, a syntax error right there. Okay, any question? Okay, so you can test out. So when you look at the book actually has many more. Okay, there are some stuff that's a little redundant compared to what we've seen in so for chapter 5, you can also use like the descriptor. Okay, this might be a good one to try to run. So in this, you are also using stem descriptor. So this comes from the stem module, and you can get server information this way. Okay, in the Tor, in the onion. Okay, so here you can get some information about your server, certificate, your key, your signing key, and your signature. So this one is also a good one to try. Then yeah, we will do a little bit more on Nmap when we get to the Nmap chapter, I think. But you can use, I think there's a section that talks about the scanning with Nmap. And so there are more different exercises for STEM. I tested this. It doesn't, it also refused connection. So you're not gonna, so this is for DuckDuckGo, and it's not gonna respond session. So you will likely get some refused connection if the site's not responding. Okay, so through all of this, you would see that the takeaway from this is you're still gonna have a way to write your script to establish socket or evaluate the response in the header. Now, only if the connection is allowed, then you will be able to see it. And then you can use some of these libraries to be able to manage how your systems are connecting with Tor. Okay. So we can establish like a virtual proxy, or even using an actual proxy with an IP address. So in this one, unlike the last one that you saw, we actually enumerate on this. So it will iterate through the group of IP addresses. And then now the IP address that you see from hop to hop, it will be different publicly. And we saw that since the exercise one, right? You saw the public IP. Public IP is not gonna be the actual system IP. It is the relay IP that is publicly seen. And you can simply view the map to really identify like those, but because they're randomly selected, you won't be able to, when you're using Tor, it's not going to be the same route every single time. Okay. Now, when we set our system as a default proxy, we're using a loopback like this, and the port that is just going to establish the virtual proxy for your system as as it connects itself to Tor. Okay, and that's just a way that we look at. So like my virtual machine is using itself as a proxy, which is it started the connection service with Tor. Okay. And as they implemented the for loop here, you would see that it would get the request from that endpoint, and then it will print out the IP address. So this is a way that you can also obtain and update your IP address as you go. And every step you're going to have different IP, so therefore they have to loop through it. So following, if you were able to follow the traffic for a system that's using Tor, it will take longer, just as Tor connects takes a little bit longer time, right? You won't be able to see who is connecting to that public IP, because when you analyze that packet, it will hide the source. you will only see the public IP of that system at that moment in time. Any question? Okay. So this gives you a little bit of practice on how to be able to use some of the concept that we've learned in HTTP programming for Tor, which is another area that we see in security for deep web, right? And be able to understand what Tor is made of and how to connect to a certain site. You don't necessarily have to use script to be able to do that. You can launch Tor using a browser or directly in your terminal. And if you visit their site, they have some information and resources there. Or Michelle shared a YouTube list or playlist that you can use. Yep. So you can play with it and be able to gain some knowledge with Tor. And definitely cool. Mastering Python network security. Oh, yeah. So that's for the class. That's correct. They openly, let me get the link for your code. Okay. I know it's at the beginning of every chapter, but let me get the link and put it in there for you in case you don't have it. Yeah, they did put some video up, and I think if you have the access to their to PacT, you can also have access to the video through there too. We get the link for your source code so you can see. Now I put it in the class, but okay, here you go. Just run code, nothing else. Yeah, for now. And I like for you to, if you can have time, then check out some of the other script, like what we talked about. And then you can examine. So 1 second, let me share screen. So if you downloaded the zip and unzip it, you would have different chapters. Okay, so we've done this one. We looked at this one. I suggest that you can look at the show descriptor. Okay, so you can look at the fingerprint of your servers. See if you can run that along with if you want to list the circuits. Okay. So there are various scripts that you can use to be able to do that. But again, right, like we say that some of these scripts, things have changed since the time they tested, and also if you don't have the valid URL, or if the connection is refused, you will not be able to get through. But at least you will be able to understand how Python can be used, right, for to scan things or to look for certain entity or connection in Tor. So like this one, we talked about this a little while about using stem control, right? So with this, you're using port 9051. And to get hidden services descriptor, those are the web servers that are for the Onion site. For this particular site, so that's equivalent to your domain information in regular HTTP. This is a DuckDuckGo, right? And if they have changed or moved or modified something from the original URL, then you will get traced back on that. So if you have the proper endpoints here, then you will be able to print out or display the port, the identifier for the server, and so on. Just like how you would scan against the real web server, right? That will give you like the port that they use, the IP address or the public IP, and some of their domain information containers and things like that. As sometimes you would need to gather the information. Okay, any question? So if you didn't submit, so this is a good time to catch up if you had a couple of things last lab that you didn't get to or things like that. So try to catch up with some of the things that you missed or one or two things, and then submit those when you can. I did update your grade as far as yesterday. If you turn in something this morning, I haven't gotten to it yet, but I will try to get all of that done by tomorrow for the current week. I won't grade anything from week 5 until next week, just to give everybody an opportunity to turn it in. Okay, and then if you have any questions or anything, please let me know. Okay, let me stop share. And then let me stop recording, but I want to share with you something.